Hello everyone. So today I'm going to be guiding you through TotalLab's latest image analysis software, Colony Counter, which can be used to count cells, particulates or bacterial colonies within images automatically without the need for additional equipment.
The new Pharetics Colony Counter software from TotalLab. Now this software is designed to not only count colonies within an image, but also to count number of cells in a cell viability assay sample, or detect particulates in, say, a water sample for water quality control, or even something as broad as, say, metal filings in a hydraulic fluid sample. At its core, this piece of software massively simplifies and automates the process of detecting particles within an image. So there are some manufacturers out there that provide automated colony counting and things like that to reduce the burden on people within the life sciences that perform this routinely. However, they typically are part of a larger system. So it's a piece of equipment that you have to buy. It's quite expensive. I don't know the exact price, but the idea is that it's all within the system. You buy the system. It's quite expensive, and you have to have that system within your lab. Our software is designed to work with images from any kind of imaging device, whether it be a microscope with a camera attached, or like a gel documentation device, or a scanner or something like that. Our software is open to all image types that you can bring in and automatically count colonies and detect colonies and take measurements, things like that. And so it's a much cheaper option to give you a lot of the benefit that those systems offer. And obviously, automated colony counting does come with the benefit of reducing human error if you're, manually going through and counting each of these colonies, not knowing if you counted a colony twice, things like that. So it does have the potential to save lab users and users in other industries a huge amount of time by automating that process and simplifying that process as much as we can. And this software is, of course, along with all of our other software, available in a 21 CFR or GMP compliant format. So if you've used any of our other Pharetics modules of image analysis software, you'll recognize this screen. So this is kind of the image setup screen. So I brought in this image, and it's not the world's best quality image. It's a JPEG image, so it's been compressed, and it's only got a bit depth of 8 bits per pixel. We would always recommend at least using a TIFF image, so an uncompressed image with at least 16 bits per pixel. And that's very much the industry standard. So any modern camera that's fitted to a microscope or scanner or gel documentation device will support TIFF at 16-bit export. So you would image your plate, your wells, whatever it may be, export the image and bring it into this software for analysis. So this is the image view. And what we have at the top left here is a representation of how the software is seeing the image. So what we want to see is our signal, the things that we're interested in measuring in this lovely teal color here, with our background being represented as black. And we can see this in the 3D view here. The colonies that we're interested in counting and measuring are represented by these high peaks, and the background is represented by the darkness behind them. So if I had an inverted image, for example, these peaks were displayed as troughs and the background was showing up very high as teal, we know that we need to come here and invert this image for the measurements to be taken correctly. And we can pop out this 3D view and save it to our clipboard, copy it to our clipboard as kind of a screenshot, or save it as a file, and then put that into marketing materials, presentations, posters. It's a really visually striking way of showing your results and producing kind of excellent quality scientific imagery for wherever you may need it. So when saved as a file, it can be imported into PowerPoint, Word, Canva, whatever you're using to produce your media. And at the bottom here, we can see the current image view. So this is the way the image has been brought in. And we've got all of the options available to us in terms of image adjustments that we have within the other Pharetics modules. So if I click here, I can change the contrast of the image and get it to display how I want it to. If it's not, say if I imported it and it showed like this, I know I need to change that. We do perform an automatic contrast and brightness adjustment when we bring images into the software that the user is not aware of. But that's not always perfect, so you do have these options to override that to try and get the best view for yourselves. We have the brightness slider up here, And we have a number of false color heat maps that we can apply to our image to increase the contrast between what we're trying to measure and the background of the image. So it's quite obvious where our colonies are on our plate here. But if I had, say, a high background signal that was very close to my colony signal, or they were very similar colored, I could apply something like a false color heat map, and this would help me massively when trying to define the edges of my colonies. Now, these are well-rounded, good circular colonies, but if I have these different species of bacteria or uneven kind of shaped pieces of debris or something in my sample, it might be quite difficult to ascertain where the edge of that debris is when you want to kind of set a boundary for measurement. So we've got all of those options available to us, and I'll just reset this back to the native color here. So we've got all those options available to us to make the job of the analyst much easier. So if I come through now to the detect mode, by default, if I left click and drag, it will give me a circle to draw around my sample, and this is the area of interest. This is where the area within the plate or the wells or whatever it is I'm measuring that the software is going to look for colonies or circles, essentially. Now, you can change this to be a rectangle, so if you're using slides or kind of square well plates or something that is rectangular in shape, you can change that to a rectangle. I'll change that back to a circle now. And you're not limited to just one circle, so you can draw as many as you want, and they will all be treated as individual areas for detection and counting. You can see that they've added up on top. So say, for example, if you used a scanner to image a 6-well plate and you wanted to get a colony count for each well within that plate, you would draw 6 circles, and this would give you the count per circle, the count per well. Now I'll just get rid of these. So you don't have to do things one by one. You can take an image of a whole plate and get the software to automatically detect colonies within those. So that could save an operator a huge amount of time if they had, say, 6 agar plates that they needed to count. They could image them all at the same time and count the colonies all within one click. Big detect button here. Rather than doing one, finishing, moving on to the next one, counting, moving on, you can see how this would take much less time, be much easier for the analyst or the operator to perform. Now, users do have the option of changing the sensitivity or the parameters of the colony detection algorithm. I'm not going to delve into that now. I'm just going to use the defaults and see how well we get on. So if I click detect here, you can see that we've now got circles marking the edge of kind of the boundaries of the colonies that have been detected by the software. And we start to get measurements from our colonies. So we get an area measurement, a circularity measurement, and a volume measurement, and we've also got other measurements that we can build into our results. And as with our other image analysis software, we can export this to a CSV file to move it into Excel and then do other things with it in other pieces of software. Or we can copy this table to our clipboard and paste that wherever it needs to go. MATLAB, anywhere else, somewhere for some processing. But by default, it's done a really good job on this image. And it's telling me that there are 227 colonies within this area of interest that I've detected. So if you do need to make any manual adjustments, or you would like to make any manual adjustments, say if there's any writing on your image, on your agar plate, or there's any aberrations or any colonies you don't want to include, or if you want to have different groups of, say you've got different groups of bacteria and want to kind of segment them off into their kind of species, you can do this. You can do this by using different circles, or you can do this manually through the manual editing mode. Now, when we come through to the edit mode, the first option is to select, so just click on one colony. Or you can detect automatically all colonies with a low circularity. Now, if I click this, you can see it's detected these areas on the edge of the image, which is kind of the edge of the plastic of this plate. It has low circularity, and I can delete those automatically. It's useful for deleting aberrations or anomalous results or anything like that. So say if you've got like a hair on this plate or just a random particulate that shouldn't be there, the low circularity detection will allow you to automatically detect those most of the time. You'll see that it has detected some of my colonies, so I'm not going to use this now. We've got the ability to draw on a manual circle, and we can left click and drag to change the size of that circle to be added to a colony. You see it's added as colony and a measurement is performed of these areas. And you can delete colonies. So if the automatic detection algorithm has detected a piece of debris on your plate or some writing or something like that, you can easily come through and delete those from your analysis. And you can also manually split colonies. So if you see these two colonies here, the software has detected them as one large colony because they overlap in the middle here. There's no distinct line that separates these two circles in terms of the image, so the software can't automatically define this as one circle and two circles. But what I can do is come through to the split tool, draw this line down, and then the software will say this is one colony, this is another colony. So you do have that kind of manual intervention if necessary, but if you can automatically detect 90% of your colonies and you need to manually adjust 10, you're still saving a huge amount of time, especially if you were doing this manually anyway. And in terms of background removal, the next step, we have two methods of background removal. We have the image rectangle. Now, if you've used 1D image analysis software before, you'll probably recognize the image rectangle as being a fairly standard method for background removal, certainly in 1D gels and Western blots. The idea here is that the software gives you a rectangle and you define where and the size of that rectangle, and the software will average the pixel value for every pixel within this rectangle, and it will come out with a number, a pixel intensity. The software will then say, this is the average background, and subtract it from every colony within your image. It's extremely useful and accurate for images such as this, where there's quite a uniform background. It's not as useful in images where the background changes quite a lot, because obviously the average value here for background will be quite different from the average value here where it's darker. But it is quite good in this image. And we do also have the mode non-spot background removal method. Now, what this does is for every colony, it expands an invisible border around the colony of this margin. So 4 at the moment is the default, so it's 4 pixels. So it will grow the circle around a colony invisibly by 4 pixels, and then take the average value within those 4 pixels around each colony and apply that as the background removal method, that average as the background removal value. So it doesn't take the average, it takes the mode. So kind of the most common pixel value within that border is then applied to each colony. So this is a much more colony to colony or per colony background subtraction method. There is a caveat with this, is you can't see where the border is. So if you've got lots of spots that are very close together, lots of colonies that are very close together, there's the potential that by growing the border around a colony, it will intersect with a section of another spot, which will obviously count towards the mode calculation to be defined as the background. So it will skew your results in a particular direction. But in a case such as this, where our spots are quite far, so you can control how far the margin is, or you can use the image rectangle in cases such as that. But this is quite a sparsely populated plate. So for the majority of colonies in this plate, mode non-spot would be a good background removal method, but we've always got image rectangle for removal as well. Now you can turn on the background results, so you can see what the background value is and what's been kind of removed and how we've reached the results that we have. And that would be a full analysis essentially. Now I've obviously sped through this for the benefit of the viewer. It wouldn't be very exciting for a viewer to watch me fine-tune the minutiae of this. But if you wanted to export the results, you can export that in the form of a PDF report from the software directly, or you can export it in terms of CSV or copy this measurements table, including whichever of these options you've turned on, to your clipboard and then paste that into another piece of software, MATLAB, SPSS, Excel, wherever you want it to go. You can just copy and paste it nice and easily. We're not locked down to any particular manufacturer. Our software will accept almost any image from any manufacturer's device, and it can massively save people a huge amount of time when trying to count colonies, particulates, cells, anything like that. So that's the Phoretix Colony Counter, the new image analysis software from TotalLab.
As ever, thanks for watching, and if you'd like to try a free copy of our colony counter software within your lab on your own images, please follow the links in the description below.